Okay, in this video we're going to do an inductive proof of a divisibility example, and this kind of question you can get in further maths A-level quite a bit. Quite nice, these ones, I think, as long as you follow the structure. So a reminder, for proof by induction, the first thing we need is a base case. In this case it's going to be n is equal to 1. Obviously I perhaps should have said n is a member of a natural number plus there. So our base case, we're going to prove that n is true when n equals 1. So base case, the left-hand side, well, we can just say 2 to the power 4 times 1 minus 1 is equal to 16 minus 1, which is equal to 15, which is divisible by 15. Clearly divisible by 15. By 15. So therefore, base case is true. Okay, and then, so that's the base case. So now the assumption, assume true when n is equal to k. Say, just give a different symbol from m. So that means 2 to the 4k minus 1 is divisible by 15. So is equal to, we can write that statement is equal to 15m, where m is a positive integer or positive natural number. So that's basically the assumption that it's true when n is equal to k, means it can be written as 15 times by some integer m. Okay, so now we're doing the inductive bit. Part. So we'll assume, no, we're going to, when n equals to k plus 1. So when n equals k plus 1, so we're going to look at when n equals k plus 1 and try and show, assuming that this is true, that it's also divisible by 15 when n is k plus 1. So let's just work with that. So we have 2 to the 4 times k plus 1 minus 1 is equal to 2 times 4k plus 4 minus 1. It's obviously equal to, using indices, 2 to the 4 times 2 to the 4k minus 1, which is equal to 16 times 2 to the 4k minus 1. Now here's where the assumption bit comes in, because we can kind of write this, for going back up to here, we can say that 2 to the 4k is equal to 15m plus 1. So we can replace 2 to the 4k. This is where the assumption bit comes in. So you don't have to write assumption in your proof, by the way. I'm just writing it here to make it clear where that part actually is coming into the inductive step. So that's 16 times by 15m plus 1 minus 1. So that equals to 16 times 15m plus 16 minus 1. And that's 16 times 15m. I'm just not bothering to multiply it out because I know I'm going to factorize again in a moment. So that's 15 times 16m plus 1. So which is divisible by 15, obviously. Divisible by 15. So therefore, that means it's true for n equals to true for n equals to k plus 1, if true for n equals k. This is the kind of conclusion bit in this bit here. So this is we're concluding now. Okay, so we've done the inductive step, but we need to refer back to the base. You must, even though you do the base, mustn't refer back to it. So since true when n equals to 1, the base case, let's write the statement out, 2 to the 4n minus 1 is divisible by 15 for any positive natural number. So that's it. That is a divisibility case using induction. Okay, that's it. Bye.